Back. This time we're going to talk about confusion matrices. Before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, confusion matrices for model evaluation. The confusion matrix is a critical evaluation tool that visualizes classification model performance beyond simple accuracy. It becomes essential when classes are unbalanced, when false positives and false negatives carry different real-world consequences, or when you need to compare a performance across multiple categories. So, why does accuracy mislead? Consider predicting a rare disease affecting 0.1% of the population. A model that always predicts no disease achieves 99.9% accuracy but provides zero clinical value. This model never identifies actual disease cases, rendering it useless despite impressive accuracy numbers. The confusion matrix reveals this failure by showing granular breakdowns of true positives, true negatives, and false negatives. So, binary classification. So in this structure, a binary confusion matrix is a 2x2 grid comparing predicted labels against actual labels. True positive occurs when you predict yes, and the actual answer is yes. False positive happens when you predict yes, but the actual answer is no. False negative means you predict no when the actual answer is yes. True negative is predicting no when the actual answer is no. So diagonal cells, true positive and true negative, represent correct predictions. Off-diagonal cells, false positive and false negative, represent errors. The matrix structure makes error patterns immediately visible. So what's a practical example of this? Let me see. All right, so can't find one. I thought I would have one saved. Okay, so imagine a cat image classifier with these results. Result 1, 50 cat images correctly identified. Result 2, 100 non-cat images correctly identified. Number 3, 5 non-cat images incorrectly flagged as cats. Number 4, 10 actual cat images missed. So the accuracy would calculate that almost 90% of these would sound great. However, the confusion matrix would reveal that 10 cats were missed entirely. So depending on your application, perhaps a wildlife monitoring system, this false negative rate might be unacceptable despite high overall accuracy. Okay, so let's see. Multi-class classification. All right. So when classifying more than two categories, the matrix expands to n by m dimensions, where n equals the number of classes. For recognizing handwritten digits 0 through 9, you'd create a 10 by 10 matrix. Each cell would show you how many true class examples were predicted as a class. These larger matrices are typically visualized as heat maps where darker diagonal values indicate more correct predictions and off-diagonal brightness would reveal misclassification patterns. This visualization quickly identifies which classes the model confuses with each other. So, in machine learning, AWS's deprecated machine learning services used a specific confusion matrix format that may appear on certain portions of the exam. The matrix included actual class rows, predicted class columns, percentage values showing prediction distributions, and F1 scores for each class. Diagonal values highlight correct predictions, while off-diagonal values show confusion patterns. Always read the axis labels carefully. Predicted versus actual positioning varies by implementations. So in AWS, confusion matrices inform critical decisions across domain. A medical AI prioritizes catching true positives to minimize misdiagnosis, like a false negative. Fraud detection might minimize false positives to prevent alert fatigue from overwhelming analysts. Document classification systems use multi-class matrices to visualize effectiveness across numerous categories. Within AWS, SageMaker Clarify and Model Monitor can track and display these performance metrics. SageMaker Studio provides the environment for generating custom confusion matrices through Jupyter notebooks using standard Python libraries. So, how does this integrate with model monitoring? Right? While confusion matrices calculation itself is free, it's just arithmetic on predictions, right? The AWS services that facilitate monitoring have costs. SageMaker Studio charges for instance usage and EBS storage. Model Monitor bills per 1,000 inference requests monitored. SageMaker Clarify charges for bias and explainability for analysis jobs. CloudWatch and Athena add costs if you track performance metrics over time. You need to minimize expenses by terminating notebooks and studio instances when not actively developing. Use Model Monitor selectively on critical production models rather than all experiments. So, to be cost aware, generate confusion matrices during model development in studio notebooks to understand performance characteristics before deployment. Once in production, use Model Monitor to track performance drift by periodically comparing confusion matrices from recent predictions against baseline performance. This targeted approach will balance monitor coverage against operational costs. So, for the exam, when questions ask about evaluating classification performance with imbalanced classes, understanding error types, or choosing appropriate metrics beyond accuracy, confusion matrices will provide the detailed view you need. So, thank you for joining. This will be all we have for today. Before we go, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.